All right. Welcome, welcome, welcome. Here we are. And oh, I'm very happy today to present to you guys another meeting talking about universal mathematics. So we had a little introduction last time, and we are going to continue because this topic is rather deep. So we're not going to finish it all in one Zoom meeting. And this will be the second meeting. We probably won't finish it in this meeting either, but we're going to jump into it. Okay, so give me just a minute or two. I have to load up some diagrams for you guys, and then we will get this going. So we had a little introduction for universal mathematics last time, and but I didn't get to put this on the screen. So you guys see my screen? It should show the formula of the lock potentials.
Yep, you can see
Okay.
it.
Okay, great. So this should have been in the last video, but I couldn't find the picture, so I just had to take one out of the universal one. This is when we say the formula of the lock potentials, this is what we're talking about. The zero representing the equilibrium, or you could call it the fulcrum, you could call it the mind of God. But the point is that you know, all motion, all power, all knowledge, all power, kind of starts here. And that substance of light starts to polarize into above equilibrium and below equilibrium, plus and minus. And so from that equilibrium point of the zero, it will, on the inhalation, I guess you would call it, it will go up to plus one, plus two, plus three, plus four. But at the same time that that's going that way, there's another one going the opposite direction on this side, minus one, minus two, minus three, minus four. Um, and that is just a general formula that controls, that kind of gives us a framework for all matter in the universe and how it behaves and what it does. And so this is where, Walter Russell is first putting mathematics into this idea of his concept of the universe that he said was shared with him, from the mind of God. And basically, the mind of God told him, go share this, go write this down in books and share it with everybody. And so that's what he did. So now, so this is the first kind of, I guess, equation or formula, rather, and it's very simple. 1, 2, 3, 4, 4, 3, 2, 1. Let's bring up a different version. You also have the same thing here. There's the zero or the inertial line. And we have the 1, 2, 3, 4, 4, 3, 2, 1. Okay. So, so that formula goes along with physical three-dimensional, the three-dimensional physical space that we live in. So, I like this. So he made this. This is another diagram from the universal one. This is on page 39. I just want to read what it says here. It's kind of a good reminder. Ooh, can I get this out of the way? Hold on 1 second. There we go. He says the formula of the locked potentials. Time marks the periods between events. And by the way, that's like the best description of time I've seen. Like, people try to say time is all mysterious and everything, but Russell just breaks it down like that. Time, it just marks the periods between events. Okay. Man divides his time by the periodicities of this planet's revolution around the sun. That would be a year. And subdivides it by its rotation upon its axis, which would be a day, right? These periods are again divided to act as man's necessary time dimension. We divide it into hours, minutes, seconds, right? The universal one divides his time by the periodicities of his inhalation and exhalation, which together make one universal constant of energy, and subdivides it into four exactly equal unit constants of energy. And I'm going to pause reading this right here because I want to show this in kind of how it connects with kind of our three-dimensional space. He's talking about this, what you see here. We have a plus one on this side and a minus one on this side. Plus two on this side, minus two, plus three on this side, minus three, and the four. And so what we have here is one, two, three, four, five, six, seven. And this is, let's see how he described. Let me go back again. 1 second. So what he said here is the universal one divides his time by periodicities of his inhalation and exhalation, which together make one universal constant of energy, and subdivides it into four exactly equal unit constants of energy. So I want to show you the four unit constants of energy he's talking about on here would be like this first pressure zone. That is, the one and the one. And then the second one would be the second pressure zone, which is the two and the two. Third is the three and the three. And then the four is the fourth one. So you've got these 1, 2, 3, 4 pressure zones, if you want to call them that, or as he says here, we can call them four exactly equal unit constants of energy. Okay, so these periodicities and tonal and mid-tonal subdivisions measure the dimensions of his idea in the illusion of form, space, time, sex, temperature, and other periodicities. And down at the bottom, I should read this too. Energy accumulates during general active inhalation by raising potential and dissipates during the radioactive exhalation by lowering potential. These periodicities of inhalation and exhalation in all mass are absolute. And, that's he kind of has this cool time clock thing. I'll let you guys study that on your own because it's kind of interesting. It's got the colors and there's the formula of the lock potentials in there, the 0, 1, 2, 3, 4. Okay, so now what he's saying here is just very important in terms of if we're going to create a universal mathematics that essentially where this math is good for anything in the universe, it's got to be tied to kind of the way that everything moves in the universe. And as we know, that's the cycle of matter. It's just, starts at inertia. There's the gravitative or inhalation, side of the equation where it's raising up the potential, going, up each pressure zone. And then there's the second half of the cycle where it's the exhalation or, the radiative part where it's then going down to lower and lower pressures. It's lowering the potential till it gets back to zero. Okay. So that's the kind of general intro there or refresher so that we can now move on to kind of where we left off. Now, I wanted to just connect, for people who maybe are just finding this video for the first time or something, this, it's kind of like a wave. Now, it doesn't show the whole thing because like at the zero line, there would be part of it going this way, but then there would be another part going down this other way. And so I want to bring the periodic table up just to show that we'll see these waves in the periodic table. And where there's this center line here is the zero, if you will. And so you'll have on one side, you'll have a wave going this way, but on the other side, you'll have a wave going this way. Okay. So that's kind of what we're seeing. And since this is the periodic table, that's all the elements. That's just all the stuff that, is in our universe, right? So that's kind of the connection. So now can go back to the chapter in the universal one. Here we go. Now, let's see. And let me find where we left off last time. So last time we were talking about how all the dimensions, as we have gone over before, the 18 dimensions of motion, Walter started talking about in terms of mathematics that we have to see these dimensions in two ways. They need to be measured in the contraction dimension and the expansion dimension. And let's see, what did he say here? So he said the plus dimension shall herein be called the contraction dimension. That's like the gravitative half of the cycle. The contraction dimension is the charging dimension of the electropositive force, which winds the cosmic clock. The minus dimension shall herein be called the expansion dimension. The expansion dimension is the discharging dimension of the electronegative force or radiative force, right, which unwinds the cosmic clock. So he essentially said we have to make sure that, well, let me just go ahead and read this. He says, all plus effects of motion have been clearly defined as generative contractive effects, and all minus effects have been defined as radiative expansive effects. It must not be forgotten that all mass is either preponderantly charging or adding to, or it's preponderantly discharging or subtracting from. For this reason, all effects of motion in mass must be measured in both of their opposite dimensions, their plus and their minus dimension. And last time we gave that example about temperature. If there was say, a planet that was close to the sun, as if this is the sun and you got a little planet here, as it expands away from the sun and it's expanding in size, the temperature is getting cooler. Most of us would just say, oh, well, the temperature is getting cooler. That's just one, but Russell is saying, no, that's just one. You're only measuring it in one of the two ways. You have to measure it in both. And so he said, let's see if it's right here. Well, it's on the last video, but I can paraphrase and just say, he was saying that in the expansion dimension of temperature, the expansion dimension is getting more intense, or it is getting colder. Okay. Now, and it's becoming greater in the expansive dimension, which is colder. But in the contractive dimension, since it's expanding, if you talk about the contraction dimension of temperature, well, it is getting less intense. It is lessening and getting weaker. And that would be the temperature, the contractive dimension of temperature is when temperature gets hotter. Okay. Like if something was coming together, it would be getting hotter. But in this case, since the planet is expanding away and it's getting bigger, we would say that the contraction dimension of heat is lessening, and the expansion dimension of cold is increasing. So it's saying the same thing, but in two different ways. So he just wants us to remember we have to know both. And that's for every dimension of all these 18 dimensions that we studied. There's always a contraction side of it and an expansion side of it. Okay. Now that we know that, now we can set up mathematics to kind of describe all of that. And so that's how we get to this lovely um, picture here, one of my favorites, which is, this universal mathematics and universal ratios. And, I love it so much. I think it's like probably one of the most important pictures in the entire book and of his whole concept because, which is why, I wear this t-shirt all the time. And, when I'm out, I get a lot of compliments about it. And people are like, oh, is that like, the flower of life or something like that? And I always tell them, I'm like, well, no, that's not what this is about. This is literally showing the mathematics and why the flower of life forms. Okay, so it actually is the flower of life. You can see it in there, but that's not, this is not just a picture of the flower of life. This is literally a picture that describes how everything in the universe works and grows and why the flower of life comes into being. So we're gonna talk about this a little bit. Um, okay, so Russell says it has heretofore been written that all effects of motion are expressed in seven equal tones of 4 units. And just one last time to um, show this one more time. The 4 units are like the pressure zones. This is 1 unit here, 1, 2, 3, and 4. Those are 4 units, but the 7 tones are the 1, 2. Well, let's see, 1, 2, 3, 4, 5, 6, 7. Those are the 7 tones. Okay. Okay. Let's see. Right. It is heretofore been written that all effects of motion are expressed in 7 equal tones of 4 units. The 7 tones of the universal constant are consecutively removed one from the other, the square of the distance to the next highest potential. The energy of each of the 4 units is exactly equal to that of each of the other. The energy of this unit, this first pressure zone, is equal to the energy of the second pressure zone. And it's equal to the energy of the third pressure zone. And it's equal to the energy of the fourth pressure zone. Each zone has the same amount of energy. Okay. So that's important to know because they are very different in terms of like how we perceive them. Something that's very high potential, like a rock, is very different than something that's very low potential, like, some just a can of oxygen or whatever, some gas or something. But he's saying, hey, they are equal in energy, but they're not equal in volume, though. Okay. So let's see here. +1, for example, is removed from +2 by the square of the distance to +3, which is the next highest potential. By a study of the accompanying dimension charts, one can readily see that any change in the expansion or contraction dimension of any effective motion is in either direct ratio or inverse ratio to the square of the distance, area, or plane dimensions, or to the cube of the volume dimension. And we're going to be going over that more in the not in this Zoom meeting, but like the next one. We're going to be going through some examples of um of how the mathematics kind of work out. Okay, let's see here. So all effects of motion are measurable either in distance, area, or volume ratios. So I want to show some diagrams about that. Oh, right. And also, all are measurable in both the ratios of contraction and expansion pressures. So this picture that we have here, um, he said that we can measure everything in either distance, area, or volume. So on the side over here, this represents distance. It's just, essentially like a line, right? And we can see the first pressure zone, which he has labeled 8. Second pressure zone is 4. Third pressure zone is 2. And fourth pressure zone is 1. Over here, when we add a second dimension, now this is area because now we've got, length and width. And we can kind of see how it's 1. Then the second pressure, I'm sorry, the fourth pressure zone is 1. The third pressure zone is 4. The second pressure zone is 16. And the first pressure zone is 64 in terms of area. Okay. Now, let's see, actually, let's go to the next diagram first. Here is another example. So here we have length. Here we have length and width. So it's the second dimension or area. And this is where on our list of the 18 dimensions, I said we didn't really go over length, width, and height, because it's kind of, we kind of all kind of understand that already. But this is the one kind of diagram in the book where he does show that. So first dimension is length or distance. Okay. And he's got it such that it's connected with the formula of the lock potentials. So here is the 0 or the equilibrium down here. And then from here up to +1, plus and minus 1, that's the first pressure zone. And then from 1 to 2 is the second pressure zone. From 2 to 3 is the third pressure zone. And from 3 to 4 is the fourth pressure zone. So that's just length. Okay. Now we add the second dimension, area, because now you have length and breadth. Okay. And now you can see how the numbers are formed. Same thing, 1, 4, 16, and what is that? 64. And then last but not least, the third dimension or thickness. Now it becomes volume, right? Because we got length, width, and height, or sorry, what is length, length, breadth, and thickness, or volume. And so we can see now it's a cube, which is that's 1 cube. And then the next pressure zone would be 8 cubes. The next would be 64 cubes. And then finally, the last one would be 512 cubes. Okay. And so this biggest one represents the first pressure zone. This one, the 64, is the second pressure zone. This one that has 8 is the third pressure zone. And this one that only has 1 cube is the fourth pressure zone. And that is, that's our formula of the lock potentials. 1, 2, 3, and 4. And then back from 4, 3, 2, and 1, and back to equilibrium. So the ratios of contraction and of expansion pressure shall herein be termed the universal ratios. And that is where we get to my favorite here, because what he's showing here now, he's doing it in spheres. These aren't just circles, but these are 3-dimensional spheres. All right, we've got 10 minutes left in this meeting. And just like over here, the next pressure zone, you got 4. So now he's able to put 4 in here. Okay. Then the next pressure zone would be 16. So sure enough, this picture of 4, then there's 4 of those in here. 1, 2, 3, 4. And last but not least, in the 64, now you can see this whole 16 sphere is here. and there's four of those in there. And it's like, it's just, I just feel like it's wonderful how these, it, how it can build up and still be, and still have the same ratios. And that buildup is how you get the flower of life. It's just literally how things come together. When they're spiraling together, there's just always these ratios, whether you're doing the compression, um, gravitative half or the expansion, radiative half, there's always going to be these ratios of how things compress and how things expand. And they're universal and they're absolute, like they don't change. Let's see what he says here. Okay. Right. The ratios of contraction and expansion pressure shall herein be termed the universal ratios. Expansion pressure is in direct ratio to the square of the distance, area, plane, orbit, or time unit, and to the cube of volume. The contraction pressure is in inverse ratio to the square of the distance, area, plane, orbit, or time unit, and to the cube of the volume. Every mass in the universe occupies a measurable potential position. With distance, plane, and area dimensions given, any planet or satellite in the solar system can be measured in all of its dimensions by contracting or expanding the standard units of this planet in universal ratios as a comparison. Now, that was a mouthful there, but he's essentially saying, oh, and I didn't get this. I should have put this. There's one more diagram. Let's see. I'll have to share that next time. But he's essentially just saying something profound there, that it's like, you know, because we know these ratios are universal and they don't change. If you want to measure something like on Neptune, which is like a very long way away, we can, by knowing our own planet measurements, we can either expand or contract, whichever way we need to go. And I guess in this case, for Neptune, we would be expanding out to Neptune. But we can figure out like what's going on Neptune just from knowing what's going on here on Earth, as long as we just use the universal ratios and in order to expand to that planet. Or if we wanted to know something about Mercury, which is closer to the sun, we would then use the contraction side. We would kind of contract our measurements to find out things that were to find out like about the planet Mercury that's closer to the sun. So it's really like it's very fascinating to me, and it's a little tough because like you would kind of have to know all of Walter's concept first, all about, the different pressure zones and, all the different dimensions. And you need to know the formula of the lock potentials, for any of this to even make sense. If someone just comes in and starts trying to read about, universal ratios, they're going to be like, they're not going to know what you're talking about. I mean, I will just, for example, so here on this diagram, this is what he says. Universal ratios. All dimensions are pressure dimensions. All dimensions simultaneously expand and contract in opposite directions of the same ratio. Okay. I've had people like stop me and be like, I want to read what's on your shirt. And, they read this. They don't know what he's talking about. Now, I'm hoping you guys, at least, since we have gone through all these dimensions, that this, like I will lose people right away when they just read this on my shirt. But you guys, this, I hope, should make some sense to you, when I read this first, paragraph and the remaining. All dimensions are pressure dimensions. We know about that. All dimensions simultaneously expand and contract in opposite directions of the same ratio. And that's kind of what we talked about when in our introduction of universal mathematics was that you remember this diagram here that, like this C and C, they're kind of connected on this seesaw. And when C expands to D and to E, well, it's still connected to this C, which is contracting to B and to A. So they simultaneously, when something contracts, there's also simultaneously something expanding. Okay, so that's what that means when he says all dimensions simultaneously expand and contract in opposite directions of the same ratio. With distance, plane, and area dimensions given, any planet or satellite in the solar system can be measured in all of its dimensions by contracting or expanding the standard units of this planet in universal ratios. Any relative dimension in any position within a mass can be determined by applying the laws of universal ratios to that position. And so, what are the laws? Here are the laws. The laws. Expansion pressure is in direct ratio to the square of the distance, degree, area, plane, orbit, or time unit, and to the cube of the volume. And the contraction pressure is in inverse ratio, which means it's going the other way, to the square of the distance, degree, area, plane, orbit, or time unit, and to the cube of the volume. Every mass in the universe occupies a measurable potential position. So that is the formula of the locked potentials in universal ratios. That's what this whole thing is about. And it's really, going to be the way that the human race can start to understand how to control matter on a much deeper level. Like we have the great machinery. Let's see how much time we have left here. Yeah, we only have about a minute left. I'm just going to say we have the great machinery and the engineering to do this, but we just didn't know this theory. Once we know this theory, we can start to use these ratios and kind of make anything we want to make. Okay, so I'm going to sign off now, and I'll see you guys.